1.4, the cosine law. So the cosine law is the relationship between the lengths of the three sides of a triangle and the cosine of any angle, or the cosine of an angle in any triangle. Okay, so there's two different equations, for one for the to find the unknown side length and one to find the unknown angle. Okay, so I already went ahead and rearranged these equations so that they're a little bit easier for you to do like the math behind it. So when we're dealing with the side length, and that's what we want to find, we want to put that side length first. Okay, and then when we're dealing with an unknown angle, we want to put the cos of that angle first. Okay, so when we take a look at the cosine law, there are two situations in which we use it. Okay, so either when we know all three sides, so for example, A, B, and C, if we know all A, B, and C, we can use the cosine law to solve for an angle. And then the other situation is when we know two sides and the contained angle. It's very important that that angle is the contained angle, right? And that just means like, I mean, this side and this side meet at angle C, right? So that's the contained angle. And again, same thing with sine law, round sides to the nearest one decimal and degrees to the nearest whole units. Okay, and just remember, triangles are not drawn to scale and they're for illustration purposes only. So it just gives you a little bit of a visual. So example 1, find the measure of the unknown side to the nearest tenth of a centimeter. So taking a look at this triangle, we have triangle ABC. Okay? So we have side A, because lowercase a is opposite uppercase, like the angle A. And then we have side B, which is 16. And A and B make angle C, and we have angle C. We need to solve for side C. So because we're solving for the side length C, we're going to use one of the three side length equations. So I'm going to circle this one because this one already has a C isolated. We don't have to sub in different variables. Okay, so we're going to solve for C squared, and we're going to sub in A squared, which is 20 squared, plus B squared, which is 16, minus 2AB, so minus 2, and these two numbers repeat. This is A and B, right? So this is going to be 20, this is going to be 16, cos C. Cos, and then this is angle C, which is 52. Okay, so subbing these into our calculators, we get 20 squared is 400, 16 squared is 256, and then don't forget this entire like expression here, -2 times 20 times 16 times cos 52, that is all one number. Okay, this is all multiplied, so don't stop after the 16, also multiply by cos 52. And I get minus 394. And I'm going to round to like the one decimal, so that's fine. Okay, so if we do 400 plus 256 minus 394, we get 262. So what we've done here is we've solved for C squared, but we want to solve just for C. So at the end, we have to go ahead and square root both sides. And by square rooting the left side, the square and the square root cancel out, and we get 16.2. And that's measured in centimeters. Example 2, find the measure of angle A to the nearest degree. So this time we are looking for angle A. So let's label the three sides. Opposite A, we're going to have lowercase a. Opposite B, we're going to have lowercase b. And opposite C, we're going to have lowercase c. Okay, so this time, because we're looking for an angle, we have to use one of these equations. And we're specifically looking for angle A, so let's go ahead and use this top equation. So we're going to have cos A, because we don't know what A is, we leave it as capital A, equals, so A squared, which is 30 squared, minus B squared, which is 38 squared, minus C squared, which is 26 squared. All over negative 2 BC. So B again is 38. Oops. C is 26. And make this a little bit nicer. 38, there we go, 26. Okay, so let's go ahead and expand the numerator. Okay, so 30 squared is 900, minus 38 squared is 1444, minus 26 squared is 676. And the denominator, we do negative 2 times 38 times 26, and we get negative 1976. Okay, so for the numerator, 900 minus 1444 minus 676 is going to give us negative 1220. And then we're going to keep the denominator as it is. We're going to keep it as negative 1976. And if we divide these, we get 0.617408906. I'm just writing all of the decimals down there. So at this point, we haven't solved for A, we've solved for cos A. So we need to get the cos off of the A. So what we're going to do is we're going to cos inverse both sides. And if you left this number in your calculator, when you cos inverse it, we get A equals 51.8. So let's go ahead and round to 52 degrees. Example 3. 2 hikers set out in different directions from a marked tree on the Bruce Trail. So what that's going to be is there's some marked tree. One hiker's going this way, one hiker's going this way. Okay. The angle formed between their paths measures 50 degrees. So that's going to be 50 degrees between their paths. After 2 hours, one hiker is 6 kilometers from the starting point. So we'll say this one's 6 kilometers. And the other one is 9 kilometers from the starting point. So let's finish this diagram as a triangle. And the question is, how far apart are the hikers to the nearest 1/10 of a kilometer? Okay, so we have this triangle, and let's label it ABC. And we want to know how far apart the hikers are. So we want to know the measurement of BC, this side. Let's call this side A, because it's opposite angle A. So because we are going to be calculating side A, we need to use one of the side length formulas. Okay, so for side A, let's use this one up here. Okay, so A squared, and we don't know A, so we leave that as A squared, equal sign, B squared, so let's label B. So opposite B, this is going to be B, it's going to be 9 kilometers. So 9 squared plus, we have C squared now. So opposite angle C we have side C, which is 6 kilometers. So 6 squared minus 2 BC, which is these two, 9 and 6 repeating, and then cos A. So this is a capital A. That means we're looking at the angle. So cos 50. Okay, 9 squared is going to give us 81, plus 6 squared, which is going to give us 36, minus 2 times 9 times 6 times cos 50. So this entire term is going in my calculator, and I get negative 69. We can put 0.42, that's fine. Okay, so now I want to simplify these three. So I'm going to do 81 plus 36 minus 69.42, and I'm going to get 47.58. Okay, at this point, we found a squared, but we want to find a. So now we have to cancel out the squared with the square root. So we root both sides, and we get a equals 6.9 kilometers. Okay, and that satisfies the nearest tenth of a kilometer. And because it is a word problem, let's go ahead and put a therefore statement. Therefore, the hikers are 6.9 kilometers apart.